Hello and welcome. So in today's video, I'm going to be covering the FlexVPN example in the CCNP Security VPN cert guide as in previous videos. And starting off, I'm going to do the Isp router, and similar to previous examples, I'm going to do static routing, a link for each one, R1, R2, and R3. So these are all going to the links for the between ISP and then the different routers, 192.168.10.20 and .30. So all the public IPs from a FlexVPN perspective are going to be for the different R1 through R3 is going to be the .2, 10.2, 20.2, 30.2. And then R1 is going to be the hub for the FlexVPN. Gig00 will be linked to the ISP. Gig01 is going to be the LAN subnet. And then just a default route to its link to the ISP. And then IKEv2 proposal, IKEv2 policy, and IPsec transform set, same as in examples in previous videos. And then for FlexVPN, it introduces this concept of using AAA authorization via network, and we're creating a list here called Flex Auth Spoke, and using the local database. And then there's this concept of the various spoke routers getting their tunnel IP address assigned, and the IP address assignment will come from this IP pool that we create. And in this case, I'm doing 10.10.10.2 through .5 as available IP addresses for spokes. And we just have the two spokes in this example, R2 and R3. And then this access list is going to be referenced for encryption domain, interesting traffic for the FlexVPN tunnels. And then also this access list gets downloaded by each one of the spokes, and then that we'll see that static routes will be assigned to these networks through the associated tunnel interface. So like this top one here is the 172.16.10 is the LAN subnet for R1, the hub router, and then LAN subnets for the spokes R2 and R3. And then there's a crypto IKEv2 authorization policy, which is new concept for FlexVPN here, different from previous examples. And then the idea here is that when the spokes initiate the tunnel and go through the authorization, their tunnel interface is going to get its IP address assigned from the pool. The static routing will go through that interface, and which access list to download for that routing. So that's kind of all encapsulated in this IKEv2 authorization policy, and it'll be referenced here pretty soon. Then with any IKEv2 tunnel, we have a keyring. Since this is the hub R1, we're defining information for R2 and R3, the different peers, public IPs for both of those, 20.2 and 30.2. And actually, before I forget, going to set up debug. So IKEv2 debug is running, and then we'll see that start. See the messages start when tunnel negotiation starts here in a minute. Okay, so we put the keyring in, and then need an IKEv2 profile, referencing R2 and R3's peer IPs, local peer IP of the R1, the hub, keyring that was just referencing the keyring that was just configured, pre-shared key. And then this is where we get to bring in the authorization parts together. So AAA authorization group, we're using PSK, and then the list that we created is up here, AAA authorization flex auth spoke, and then after that we're putting in the reference to the IKEv2 authorization policy, what I'm calling flex policy spoke. So it's tying in the whole authorization stuff is being tied in the IKEv2 profile and referencing the AAA authorization and the IKEv2 authorization policies. And virtual template 1 is going to be the interface where this is all happening. And then the spokes will have a standard tunnel interface. And then IPsec profile, referencing the transform set that we want to use for phase 2, and referencing the IKEv2 profile that was just configured. And then when we get to the virtual template interface, we'll call the IPsec profile to tie it all together. And in the example in the book here, they have you using a loopback interface and using this IP unnumbered. So, and I'm just setting the IP address of 10.10.10.1 to kind of keep kind of a straightforward set of IP addresses. So the tunnel interface will be, or sorry, the loopback interface for the hub R1 is going to be 10.10.10.1, and then any and then we'll see that the virtual access is gonna, on R1 virtual access interface, it's gonna get the .2, and then R2 and R3, their tunnel interfaces will be .3 and .4. So create the loopback 0. And virtual template number 1, type tunnel, just using the syntax from the example in the book, referencing loopback 0, tunnel source gig 00, because that's what's facing the ISP, and tunnel protection is that IPsec profile, which references transform set, and then the IKEv2 profile, which then IKEv2 profile references the keyring and authorization and links everything up. And then DHCP configuration, just like in the previous videos for the LAN subnet for R1. Okay, and then move to R2, one of the spokes. Put in interface for ISP and interface for LAN subnet, and then just a default route going to the ISP via gig00. IKEv2 proposal, IKEv2 policy, and IPsec transform set. Same as in other examples. And same, setting up a AAA authorization list, and the access list that's going to be referenced here, having the network for the LAN subnet. And then IKEv2 keyring referencing the IP address, peer IP for the hub, and the pre-shared key. And then same concept with IKEv2 authorization, just a different name of the access list. And then routing will happen through the static routing will happen through the tunnel interface. IKEv2 profile, peer IP of the hub, local peer IP of R2, keyring, it was just referenced keyring that was just created, and then same concept as the other one, R1 the hub, authorization, pulling together the AAA authorization policy and the IKEv2 authorization policy. And IPsec profile, same concept as before. And now any of the spokes are going to have the standard tunnel interface, IP addresses negotiated and assigned from the IP pool defined on the hub. And then the same concept, IPsec profile to protect that traffic, and then links the rest of the IKEv2 configuration. And DHCP for the LAN subnet. And then we can see the line protocol on the tunnel 0 interface came up, which is a good indication. So now we can see the debug messages running on R1 because we had debug running. So pretty much as soon as I configured the tunnel 0 interface on R2, that's when the FlexVPN or IKEv2 tunnel negotiation started here. So if I go back to R2, to show IP interface brief, we can see that tunnel 0 interface is up, which is good. It actually got the .2, so when it got its IP address negotiated, it got the .2 from the IP pool. And then let's look at R1. Okay, so the R1, I may have just been remembering it differently from doing this lab previously, but so R1 loopback interface 10.10.10.1, and same for the virtual access. And the virtual template, generally what I've seen just doing the lab and examples, the status will be up, the protocol is down, and that's normal. And then once the tunnel actually builds with one of the spokes, we get this virtual access interface. So that all looks good. We can see the tunnel built here. We've got the 20.2, which is the R2 spoke, its peer IP. Take a look at the IPsec SA. The interface is virtual access 1. And of course we haven't sent any traffic yet, so we don't really have any endcaps or decaps, but the tunnel is definitely up. So that's good. And jump to R3, and same exact concept of configuration since it's a spoke, just like R2. So I'm going to paste all that in. And I don't think I turned debug off on R1. Yeah, debug's still running, so we'll see that kick in once R3 is totally configured. So I'll just grab a chunk of configuration here and paste it in. And I think what we'll see here is the tunnel interface for R3 is going to get 10.10.10.3 once it negotiates. And then line protocol on tunnel 0 is up, which is a very good indication. And again, soon as that tunnel interface came up on R3, we see the debug messages on R1 because that tunnel is building for this, spoke to hub. So basically right now we have a R2 spoke to hub R1 tunnel for FlexVPN. Same thing between R3 and R1. And the reason why all three of these LAN subnets are going to be able to communicate with each other is because of the downloading of the access list that are configured. So we do show crypto IKEv2 SA. We got the tunnel up, and for the hub now we see we've got the two separate tunnels up, 30.2 for R3, 20.2 for R2. Do show IP interface brief, and then sure enough, the tunnel 0 interface on R3 negotiated and got the .3 IP address from the IP pool. If I do show IP route, we have static routing associated with the tunnel interface. So for instance, the R3 LAN is 172.17.20.0. So you can see that connected on via gig01 like we would expect. And 172.17.10.0 is connected via the tunnel interface, which was, and we got that through the access list. So 172.17.10.0 is the LAN subnet for R2. And that happens with the, where's it at? Route set interface and access list configuration that we've got going on. So it got this from R1. The route for this 172.10 or 172.17.10.0/24 over the tunnel interface, and we got that by downloading the access list from R1. And then the 172.16.0.0/24 is going to be the LAN subnet for R1. And we can see the route for that is also over the tunnel interface. So basically, this route right here to the hub R1, its LAN subnet, and then this route right here to R2's LAN subnet are both learned over the tunnel interface. And then we'll see same concept on the R2. So we got the route for R1's LAN subnet and the route for R3's LAN subnet, both via tunnel 0 interface. And so basically the major drawback to this is if you want this kind of routing through your FlexVPN, number one, you don't have, in this configuration, you don't have dynamic spoke to spoke, which I'll do in the next video. And if you want to have more information for routing, then you have to take down the tunnel, modify the access list, and then cause the tunnel to renegotiate between the spoke or spokes, so they can download that ACL and get static routing for anything that you've added. So limited, and it'll be much better when you get spoke to spoke and just do dynamic routing over those tunnel interfaces versus setting those on access lists. And so that's pretty much it, other than starting up the Linux hosts on the LAN subnets and just making sure that the traffic actually starts to pass. So I've got those links up, or at least connected, and booting up the Linux host here. So we're on the one for R2's LAN. And it's got an IP of 172.17.10.2. So do a ping from the one on R3's LAN, 172, what was it? .17.10.2. So pinging the Linux host on R2's LAN, network unreachable. And I don't have the routing table didn't populate on this one for some reason because the DHCP did not populate, which sometimes happens on these. So I'm going to stop this. I'm going to remove it. And add one back in. Let's see if this one worked. It did. So we should have the default gateway in here, which it does. So this one, 172.16.10.2. So I'll ping that one. So from the Linux host on the R2 LAN, pinging the host on R1's LAN. And so if I look at, now that I'm sending traffic that's actually going across and being encrypted on the tunnel, if I do show crypto IPsec SA, can see that I'm getting NCAPs and DCAPs for this across this VPN tunnel now. And as those pings continue to go across, then more NCAPs and DCAPs. So we know that the tunnel's up and it's definitely getting protected by IPsec from R2's LAN to R1's LAN. Let's see if the Linux host for R3 wants to work and actually get its DHCP info. Because I really mostly want to show communication between the two spokes going through the hub R1. In the meantime, so if I do a trace clear, if I do a trace route to 172.16.10.2, then I should just be seeing tunnel interfaces, default gateway, and then two tunnel interfaces. Or just one in this case. So default gateway for the LAN, tunnel interface, the virtual template or virtual access interface for R1 makes sense because it hits the default gateway. It gets encrypted for the FlexVPN between R2 and R1. When it gets decrypted, it's on the virtual access interface and then hits the final destination. Okay, so this one's going to be, it's going to be difficult, this Linux host. find this happens every once in a while. And it's not getting the DHCP info. So did I miss doing that? I don't think I did, but it's possible. Okay, so I probably just missed it then. Just for good measure, make a new Linux host here. Start to boot it up. Okay, so now we got an IP address. 172.17.20.3. So we'll ping 172.17.20.3. Is that what it was? 172.17.20.3, yep. And that does ping. I'm gonna do a trace route. And I guess in this case, we'll see two tunnel interfaces, possibly. Yeah, that makes sense. So it's going from run R2's LAN, hits the default gateway for R2, hits the tunnel interface for R1, and then down to the tunnel interface for R3, and then to the final destination. And then do the same from R3's Linux host. So that's going to be 172.16.10.2. Which pings. And we'll do a trace route 172.16.10.2. Tunnel interface of 10.10.10.1. And then tunnel interface of 10.10.10.2. And then the final destination there. So yeah, that's pretty much it. Again, just doing the example like they have in the book here. Hub to spoke setup for FlexVPN, IKEv2, and introducing this concept of the virtual template interface. And the interesting thing about that is when you virtual template interface gets configured, and then for every spoke that registers on this FlexVPN, then we get virtual access 1, virtual access 2, and then it looks like that just keeps increasing for every spoke that kind of negotiates and authorizes with the IKEv2 tunnel. So yeah, good working example there without too many mistakes. Hopefully that was helpful, and I'll see you on the next one.